Hello everyone, we are final year students from the Department of Electrical and Electronics Engineering of Microchemical Engineering College. I am Dwarna, and along with my batchmate Ariswar, we have developed an innovative project titled a new automated solar powered fishing system with RFID tagging as a part of our final year research and development work. Our project is a new automated solar powered fishing system with RFID tagging. It is designed to reduce manual effort in fishing by automating the process of net launching and retrieving with the help of sensors, GPS and extra communication modules. The boat operates intelligently to enhance efficiency, improve safety and support sustainable fishing practices. We used both Arduino Mega and Nano to divide the control and data processing responsibilities. The main objective of the project is to create a smart fishing system that integrates solar energy, automation and IoT. It aims to reduce the physical labor of fishermen while improving the monitoring and control of fishing activities. We also ensure environmental protection by avoiding deep waters and dangerous zones using sensors. Additionally, the project is designed to promote secure and authenticated access, remote tracking and efficient data logging. Implemented our system using two Arduino boards, Nano and Mega. The Nano board handles user interface components like PN532 RFID, keypad, buzzer, timer and LCD. The Mega board manages motors, sensors, communication modules and automation. We utilized various models. They are manual, IoT, automated. Each models are programmed for specific control strategies. All the modules are powered by a solar-based battery and connection through proper serial communication between boards. Our block diagram clearly shows the interaction between the modules. The Arduino deals with the RFID, keypad, buzzer, LCD and timing functions. The Arduino Mega manages the DC motor, stepper motor, servo motor, GPS, GSM, IoT module, load cell and environmental sensors. Power is supplied through a solar panel and a step-up converter. The block diagram clearly shows the overall system architecture and including data flow and control decisions. This is PN532 RFID module. The PN532 RFID module is used for secure authentication. Only authorized RFID cards can activate the system. When a valid card is scanned, the system welcomes the username and allows them to choose between manual, IoT or automated modes. This is the 4x4 matrix keypad. The 4x4 matrix keypad is used to select the desired operational modes after authentication. It allows secure and user-friendly interaction with the system without needing a touchscreen or mobile app. This is I2C LCD display. The I2C LCD displays real-time system messages including RFID status, mode selection prompts and feedback on sensor activity. It serves as the main user interface for the onboard system. This is buzzer. The buzzer provides audio feedback alerting the user during authentication, mode switching, when any abnormal condition like sensor triggered stops occurs. This is TM1637 timer module. This module sets the total operational time allowed in the sea. Once the preset time elapses, the net is automatically retrieved to ensure safe and efficient fishing within time limits. This is 12-volt DC motor. The DC motor drives the boat. In automated mode, it stopped automatically if depth or temperature exceeds safe limit. In manual and IoT modes, it is controlled via joystick or web interface. This is stepper motor. The stepper motor moves the fishing net back and forth. It is controlled manually via the joystick or remotely via OTT. It also responds to load cell input for automatic net retrieval. Servo motor 1. This is servo motor 1. This motor launches the fishing net into the water. It can be activated manually via IoT web page or automatically based on ESP32 cam fish direction. Servo motor 2. This is servo motor 2. This motor adjusts the rudder or propeller direction, helping the boat steer. It is operated based on joystick input, obstacle detection or IoT commands. This is ESP8266 Wi-Fi module. This module hosts a web page for remote control. Users can access that boat controls, launch the net, steer it from any device connected to the same network. This is ESP32 cam. The ESP32 cam streams underwater images into a web page. It also performs fish recognition automated mode and triggers net launch automatically when fish are detected. This is Neo 6M GPS module. The GPS module continuously tracks the boat's location. Its coordinates are shared with the user through GSM communication for safety and monitoring. This is GSM Ping. This module allows real-time communication. When a call is made to SIM card, it responds with a boat's GPS coordinates and sensor data like water depth and temperature. This is water temperature sensor. This sensor monitors water temperature. If it exceeds 32 degrees Celsius, the system stops the motor to avoid overheating or ecological damage. This is ultrasonic sensor. This sensor measures how deep the water is. If the depth exceeds 1000 meters, the DC motor is stopped to prevent dangerous conditions. This is obstacle sensors. These ultrasonic sensors detect nearby obstacles such as rocks or other boats based on sensor feedback. The servo motor adjusts the boat's direction to avoid collisions. The MPU 6050 detects abnormal motion or tilting help to identify risks like waves, imbalance, or tsunamis. It ensures safety in unpredictable conditions. This is moisture sensor. This sensor checks moisture level near the Arduino casing, protecting the electronics from accidental water entry or leakage. This is anemometer connected to the A169 current sensor. Wind speed is calculated using a mini turbine connected to a DC motor. The current generated is measured by the A169 sensor to estimate wind intensity. This is load cell. The load cell measures the fish weight up to 100 kg when sufficient load is detected. It signals the stepper motor to retrieve the fishing net automatically. This is SD card module. All critical data like temperature, depth, fish weight, timestamps are logged into the SD card. This supports future analysis and validation. We implemented a PN532 RFID system to authenticate users. Only authorized can access the system once a card is scanned. The LCD displays a welcome message with the user's name and allows more selection via the keypad. This ensures the system can be misused or accessed accidentally. Each RFID card is linked to a unique user identity, adding a layer of security to the phishing operation.
Good morning to all. I am Ariswar. Now I am going to talk about manual mode. In manual mode allows the user to control the boat with a joystick. The S-axis control the direction through servo motor 2, while the Y-axis control the stepper motor to move the net. Pressing the joystick like button triggers servo motor 1 to launch the net. This mode is especially useful in shallow water or when human decision making is necessary, offering complete manual flexibility to the user. Now I am going to talk about IoT mode. In IoT mode, the system connects to a local network through the ESP8266 module, which has a web page. From this interface, user can control the boat remotely, launch the net, and steer motor. Additionally, the ESP32 can stream underwater footage. If fish are visible, user can trigger the net manually by passing a button on the web page. This remote control method brings flexibility and convenience to modern fishing.
In automated mode, the boat operates completely on its own. Sensors detect temperature, depth, and obstacles. The area with abundant fish population was found by using thermal constraint and depth constraint. If the temperature of the water goes above 30 degrees Celsius and depth exceeds 1000 meters, the boat is stopped for fishing operation and it automatically launches the net using servo motor 1. Track and boat obstacles are detected by using 3 different ultrasonic sensors mounted at different angles in the boat. This mode is ideal for minimal human intervention and full autonomy. For live tracking, we integrated a Neo 6M GPS module to determine the boat's location. This data is sent to the user via The SIM 800L GSM module. When a phone call is made to the SIM module, it responds with the board's coordinates and sensor values. This system adds safety and transparency to the phishing activity and helps in the case the board needs to be located quickly in emergencies.
Finally, now I am going to talk about data logging. To analyze and store phishing activity, we added an SD card module. Thank you for watching our demonstration. This is our innovative project support fishermen by reducing manual effort, improving safety, and promoting smart fishing practice. We are proud to present our project on the FT portal and we scope its contribute positively to the goal of Ahmedabad, Bharat and Digital India.